Welcome to all. The next lecture that is on solving system of linear equations by matrix method. So in the last lecture, we discussed that how to solve the linear equations by the matrix method, means the rank method, and we told you the procedure. So now let's take some examples how to solve the linear equations by this method. So first we take the two variable system of equations. So if we have the equations are two variables equations, that is 2x plus 3y is equal to minus 1, 3x plus 2y is equal to 1. So now our first step is that we have to make the augmented matrix. So our augmented matrix is we find the augmented matrix by the combination of A and B. And what is A? A's are the matrix of coefficients of the variables, and B is the constant terms matrix, that is minus 1 and 1. Now this is our C matrix. So to determine the solve the equations, and we need to find the rank of C and the rank of A. So now first we find the rank of C, and to find the rank of C we have to convert this into the echelon form. You know it very well how to find the rank. So now first we find the rank of this whole matrix. So we need here 1. So first we divide our first row by 2. So now we have R1 is this. Now after that we need here 0 to form the echelon form. So we make here 0, and when we do it, if we subtract R2 minus 3r1, when we do r2 minus 3r1, so here we have become the 0. So now our r2 is become like that. Now to become here 1, we can multiply with minus 2 by 5 in r2, then we get here the 1. So now our r2 is 0, 1, minus 1. Now you can see this is is in the echelon form. And if we want to decide the rank of this matrix, so we here how many non-zero rows we have two non-zero rows. It means that the rank of C is 2. And if we see the rank of A, so how many rows in non-zero rows in matrix A? Here we have also the two non-zero rows. It means the rank A is again 2. It means we have rank A is equal to rank C, that is 2, and also we have the number of unknowns are 2. So which type of solution we have? Here we have the unique solution, right? After that, now we find the solution of the equations. So we write out the matrix A, and this is our the X matrix, variables X, Y, and this is our the B matrix. So now we make the equations here. So it is X plus 3 by 2 Y is equal to minus 1 by 2, and second equation is become Y is equal to minus 1. Now we solve these equations, and already we have here the value of Y. So we put this value of Y in our the first equation. So we get the value of X, that is 1. So now our solution of this linear equations are X is equal to 1 and Y is equal to minus 1. So like that, by the rank method you solve your linear equations. Now let's take the three variable equations. So if we have these three variables system of linear equations, so first of all our first step is that we have to make the augmented matrix. So our augmented matrix C is the combination of A and B, where A is the coefficient matrix, that is 2 minus 1 minus 1, 2 minus 1 minus 1. Then coefficient of the second equation is 1, 2, 3. So we put here R2 is 1, 2, 3. And the third equation coefficients of variables are 3, minus 2, 1. So that become our third row, 3, minus 2, 1. And B matrix, this is our the constant terms, 5, minus 2, 2. So now this is our the augmented matrix C. So now we find the rank of this C matrix. So to find the rank of this matrix, we convert into the echelon form. So here we need 1. And how can we take here 1? If we interchange R1 and R2, because we can use this operation, we can interchange any rows to other row in our matrices. It doesn't affect our matrix. So first step we do here, we interchange R1 into R2. So now like that our R1 is become this R2. After that, to convert into the echelon form, we made here 0. right? We will make here 0. So first we make here 0. So to make here 0, we use the operation R2 minus 2R1. If we apply this R2 minus 2R1, so it becomes 0. Other numbers may be anything, it isn't issue. Our first motive is that we have to make here 0. So now we use here R2 minus 2R1. So according to this, our R2 is become this, and this becomes 0. Other elements minus 5, minus 7 and 9. In whole matrix we have to apply this. Now after that we need 0 here in place of 3. So we use here R3 minus 3R1. When we apply R3 minus 3R1, so it becomes 0, and now our R3 is this one, 0, minus 8, minus 8 and 8. Now to convert into the echelon form, we make here 1, so we can interchange R2 and R3. So if we interchange R2 and R3, so our R2 is become like that, 0, minus 8, minus 8 and 8. Now to make here 1, we can divide the R2 by minus 1 by 8. Multiply by minus 1 by 8 in R2. Sorry, this is R2, not R3. Sorry here. So we divide this R2 by minus 8. So we become here our R2 is 0, 1, 1 and minus 1. After that, we have this one, and here to make here 0, in the last slide we make here 0, we use this R3 plus 5R2. When we apply R3 plus 5R2, so it becomes 0 here. So now our R3 is become like that. Now to make here 1, you can make it, and so we divide it by minus 2. If we divide our R3 by minus 2, so now our R3 is 0, 0, 1 and minus 2. Now you can see here, this is matrix convert into the echelon form. Now we can decide out the rank. What is the rank of this whole matrix? How many non-zero rows here? Here we have the 3 non-zero rows. So the rank of whole this matrix, augmented matrix C, is 3. If we see the rank of A, and our rank of A, matrix of A is this, and here we can see that also we have the non-zero rows are 3. It means the rank of A is also 3. So our rank A is equal to rank C here, that is 3, and 3 is also the unknown solve. We have 3 x, y, z. So which type of solution we have? We have the unique solution in this case, because both matrices have the same rank, and this is also the number of equal to the number of unknowns. So our solution is unique solution. So now we find the unique solution, and from here we made out the equation. So that is x plus 2y plus 3z is equal to minus 2. Second equation is y plus z is equal to minus 1, and third equation is z is equal to minus 2. So now by the back substitution we find the values of x, y and z. We already have here z is equal to minus 2. So we put this in equation 2 and find the value of y, that is 1. And now we put the values of y and z in equation 1. So we get the value of x, that is 2. So like that our solution of these linear equations are x is equal to 2, y is equal to 1 and z is equal to minus 2. So like that you can solve your linear equations by the matrix method. Now let's take some other types of examples here. Suppose you know that you have to find here, you have these 3 equations and you have to show here that these systems are consistent or not. So we have to show that this system is not consistent. So what is the how to decide the consistent and inconsistent? I earlier told you that the consistent system, when is your rank A is equal to rank C, it means that your system is consistent. If your rank A is not equal to rank C, it means that your system is not consistent. So here again first we take out the augmented matrix C, that is the combination of A and B, and where A is the matrix of coefficient matrix, that is 2, 6, 0, because Z is coefficient here is 0, so we put here 2, 6, 0, and here the coefficients are 6, 20, minus 6, that is our R2, and the R3 x coefficient is 0 here, so it is 0, 6, minus 18, and here we have take the constant terms, that is minus 11, minus 3 and 1. So like that this is our the augmented matrix. Now we convert this into the echelon form and decide the rank. So here we need to make the 0, right? So how can we become here 0? If we subtract R2 minus, if we apply this operation R2 minus 3R1, then it becomes 0. So we can use this R2 minus 3R1. So now our R2 is become 0, 2 minus 6 and 30, and R1 is same and R3 is same. It doesn't affect on R1 and R3, only effect on R2. Now, after that, we need here 0 here to convert into the echelon form. So, how can we do it? We use here the operation R3 minus 3R2. So, we use this R3 minus 3R2. So, like that, our R3 is become 0, 0, 0 and minus 91. Now, this matrix convert into the echelon form. Now, we decide the rank. What will be the rank of this whole matrix? C. So what's the rank? Here how many non-zero rows we have? 3 non-zero rows. It means that the rank of C is 3. But if we talk about the rank of A, we have the rank is A matrix is this. How many non-zero rows here? Only we have the 2 non-zero rows here. It means that the rank of A is 2. So now our rank A is 2 and rank C is 3. So what does it mean? Here your rank A is not equal to rank C. It means that our system is not consistent, right? It's not consistent. What does it mean? That no solution of these equations, not possible any solution of these type of equations. Clear? Okay, let's take another example, and that is very important example to ask in your uh, exams, that here you have to check the consistency and solve this. So first we have to check that this system is consistent, and after that we have to solve it. So now first thing is that we have to make this augmented matrix C, that is the combination of A and B. This is the coefficient matrix, and now we find first the rank of this matrix. So we need here 1, so we divide first R1 by 5. So now our R1 is become like that. After that, to become here 0 and here 0, so we can use these two operations together, and so we use here R2, change in R2 is R2 minus 3R1, and change R3 is R3 minus 7R1. When we apply R2 minus 3R1, so now our R2 is become like that. When we apply R3 minus 7R1, so our R3 is become like that. So here we have the zeros. Now after that, we can use this one R3 minus, if we do R3 plus 1 by 11 R2, so it becomes 0. So now we use here R3 plus 1 by 11 R2. So now our R3 is all become 0. So now we can see that this is converted into the echelon form. Now we decide the rank. What will be the rank of this whole matrix? How many non-zero rows are here? We have here the 2 non-zero rows. It means the rank of C is 3. And if we talk about the rank of A, here we also have the 2 non-zero rows. It means that the rank of A is again 2. So rank A is equal to rank C, but that is 2. And this is the less than of number of unknowns. How many number of unknowns here? 3. X, Y, Z. Number of unknowns are 3. And our rank is, both matrix rank is 2. It means that which type of solution of these equations? If we have this type of condition, it means that our solution, we have the infinite number of solutions of these equations. So now how can we find these infinite number of solutions? So let's see here. Here we have this type of system after solving. This is our A, this is our X, this is our B. Now we make the equations here. When we make the equations here, so it becomes X plus 3 by 5Y plus 7 by 5Z is equal to 4 by 5. And the second equation is 121 by 5Y minus 11 by 5Z is equal to 33 by 5. So now like that we have this type of two equations. Now how can we solve these equations? Here we have the three unknowns and two equations. We can solve these equations. We can solve these equations, but to solve these equations we have to put any scalar quantity of any variable. So just suppose we put z is equal to k. If we put z is equal to k, so we can find easily the y from the second equation. So we put z is equal to k here, then our y is 3 by 11 plus ak by 11. After that, now we have the y and z in terms of k. So from the first equation, we can calculate our x, that is minus 16 upon 11k plus 7 by 11. So now we have the values of x, y, z in terms of k. And k, what is k? K is any scalar quantity. So it means that any scalar quantity, it means that we have the number of solutions, means you can put k is 1, 2, 3, 4, 5, any value you can put in place of k, so you will get the solutions, means you have the infinite number of solutions. So if you have this type of situation, it means that you have to put any variable. It doesn't necessary that you put z is equal to k, it's depend on you. You can put y is equal to k, so it doesn't issue that you put only z is equal to k. You can, here you have the different type of solutions you have, means someone suppose that put z is equal to k, so you will get this type of answers you have. And suppose anyone get y, put y is equal to k, so you have the different number, different solution. So why? Because you have the infinite number of solutions, so any type of solutions you have in terms of k, right? So your solution is this. So like that, to find, you can find the infinite number of solutions. So always remember this, you have to put any variable in terms of an scalar quantity, then you solve another variables, right? Okay, let's do some other example, and this example is very important example, means you can find anywhere this type of examples. And this is uh, so here actually you have to find the values two, in these three linear equations you have two constants are here, lambda and mu. So in this question you have to find these values, the values of constants, not the values of x, y, z. Here you have to find the values of these two constants, and it is given that you have the no solution, unique solution, or infinite number of solution. It means that you know that which type of solution you have. If your solution is no solution, so what in that case what will be the value of lambda and mu? If your solution is unique solution, so what will be the value of lambda and mu? And if you have the infinite number of solutions, so what will be the value of lambda and mu? So like that you can solve it. So first we know what which type of solution we have, but for this, what is first thing we have to make the augmented matrix. So first we make the matrix A, so that is the coefficient matrix. 2 3 5, that is first row. 7 3 minus 2, that is second row. 2 3 lambda, that is our third row. And this is our the x matrix, variable matrix, and this is our B matrix, constant terms 9, 8 and mu. Now we make the augmented matrix. So our augmented matrix, that is become the combination of A and B. Now find the rank of this matrix. To find the rank of this matrix, we convert into the echelon form. So first we divide our R1 by 2. So it become, now our R1 is this. We have here 1. After that we need here 0, right? To convert into the echelon form, we need here 0. So we use here, apply the R2 minus 7 R1, and to become here 0, we can use R3 minus 2 R1. So we use here this one. When we apply R2 minus 7 R1, so this becomes 0. Now our R2 is this. And when we apply R3 minus 2 R1, so it becomes 0. And here we have this matrix as this. So automatically, actually, this here is also becomes 0. So you don't need to make here 0. When you apply this, it's already 0. So now it converts into the echelon. Now decide the rank. And here in this question, we have that we have the no solutions, means we know the solution, only just we have to find the values of these constants. So if our solution is no solution, so in that case what condition we have? So you have to remember the conditions. What is the condition of no solution? The condition was rank A not equal to rank C. So if our solution is no solution, it means that our rank A not should be equal to rank C. And when it is possible, if our rank A is 2 and rank C is 3, right? So when our rank is 2, if we suppose put here lambda minus 5, if becomes 0, it means that rank is 0. So rank is 2 and the rank of C will be 3. So we can change here, means our lambda minus 5 should be 0. It means what will be the value of lambda? That is 5. And what about mu? So if we need rank A not equal to rank C, it means it should not be equal to 0. So mu minus 9 not should be equal to 0 means the value of mu is not equal to 9. So like that, if our solution is no solution, it means we have these two values of our lambda and mu. Second one is unique solution. So what is the condition of unique solution? That rank A is equal to rank C, and this is also the equal to the number of unknowns that are 3 here. So now it means that the rank A should be 3 and the rank C should be 3. So when the rank A should be 3, if lambda minus 5 not equal to 0, it means that lambda should not be equal to 5. And what about mu? If suppose this is not equal to 5, so this 7, this matrix C, this is again we have the rank is C, sorry, rank is 3, right? So it doesn't affect this mu. Mu doesn't affect any role here to make the matrix C the rank, decide the rank. So mu may be any value. It doesn't affect. It may be 9 or it may be 0 or non-zero. It doesn't affect because this is not equal to 0. It means that rank will be 3, right? Now, next case is infinite number of solutions. So what was the condition for infinite number of solution? Rank is equal to rank C but less than the number of unknowns. And we have the unknowns is 3. It means it should be both rank should be 2. And when it is possible, if lambda minus 5 is 0 and mu minus 9 is 0, then the rank of A is 2 and the rank of C is also 2. So it means that lambda minus 5 is equal to 0 and mu minus 9 should be 0. It means we have the values of lambda and mu is 5 and 9. So like that, use these conditions, we can find the values of lambda and mu for the different solutions. Clear? Now we talk about the homogeneous equations. Till now we talked about the non-homogeneous equations where we have the Ax is equal to b type of equations, and here now we talk about the homogeneous equation. What are the homogeneous equation? If our Ax is equal to 0 means we have not the constant term, that constant terms are 0. So now how can we solve the equations? So you can see here the flow chart of this. We have initially the system of homogeneous linear equations, that is Ax equal to 0. So if you have the homogeneous equations, in this case you must have a solution. It doesn't issue here that you have no solution. You have always a solution. So in that case you have only matrix A, not the C matrix. So you have to find the rank of this A, and you have to decide if your rank A is equal to the number of unknowns, then you can say that your solution is unique solution, or you can say the trivial solution. What is the trivial solution? Always this solution is equal to 0, means all unknowns you have x, y, z, any variables you have, that all values are 0. If your rank A is less than number of unknowns, in that case you have the infinite number of solutions, or you can say that non-trivial solutions, right? In that case you can find the solutions, right? And if you have the trivial solution, it means that the solution is always x is equal to 0, y is equal to 0, z is equal to 0, right? So let's take an example for this. Here actually we need to here again to find the value of this constant b, and these homogeneous equations are given. First, if our solution is trivial solution, then what will be the value of b? If our solution is non-trivial solution, so what will be the value of b? So first case is we have the trivial solution. If we have suppose trivial solution, in earlier slide I told you that if our solution is trivial solution, so whatever equations you have, your solution is always x is equal to 0, y is equal to 0, z is equal to 0, because you have here 3 unknowns. And so it doesn't issue here the value of b. B may be any value, it doesn't affect the solution of the equations, right? So now come to the non-trivial solution. So if we have the non-trivial solution, what does it mean? It means that you have the rank of A is less than the number of unknowns. So first we make here the matrix A. So that is the coefficient matrix of the variables. 2, 1, 2, that is our first row. 1, 1, 3, that is our second row. 4, 3, B, this is our third row. So now we use here the operations and convert into the echelon form to decide the rank. We change R1 into R2. So now our R1 is become 113. After that we need here 0. So now to make here 0 in these both rows, first element 0, we use R2 minus 2 R1 and R3 minus 4 R1. So we use here, when we use R2 minus 2 R1, so this becomes 0. Now our R2 is become this. When we apply R3 minus 4 R1, so now our R3 is become this. After that, we need 0 here. So how can we make here 0? If we subtract R3 minus R2, R3 and R2, so we make here 0. So now we apply here R3 minus R2. So now our R3 is become like that. Now, this is into convert into the echelon form. Now we decide the rank. And what is the condition of non-trivial solution? In non-trivial solution, we have that rank A should be less than the number of unknowns. So when the rank should be less than of unknowns means less than 3 because unknowns are 3. If it should be 0, B minus 8 should be 0 to become the rank less than 3, right? So here we have B minus 8 is equal to 0. It means that B is equal to 8 is the value, means the value of B is 8 here. In this case, if our solution is the non-trivial solution. Clear how to solve the linear equations by the matrix method? So thank you. Today's lecture is completed now.